Hey there folks, Mr. G here with another educational video. This is a follow-up on our last video where we were talking about the ambiguous case for sine law. This time we're going to look at some examples that have two different answers, where the same pieces of information can actually give us two possible triangles. Just like last time, we start with one angle and two sides. I'm going to quickly sketch this out. With our first piece of information here, it looks like we could definitely connect this triangle over here with our other side A, but it also looks like we could angle our side this way and also get our triangle to close. And as we'll see, this is the case, and this is going to be an example of our ambiguous case, where we get two different answers. Starting with our sine law, then rearranging. Once we rearrange, we can plug in our numbers, get sine of this angle. Once we get the sine of the angle, plug it into our inverse sine, and we can get our reference angle here of about 47.5 degrees. Keep in mind, this is only one of our answers. The other angle in quadrant 2 that has the same reference angle is shown right here, and we can calculate it by doing 180 minus this. So as we see, we will either have an angle of 47.5 degrees or 132.5 degrees. Now let's think back to the line of reasoning we did before, looking at the size of A and B, and then the angles for A and B. Since A is 7, B is 9, A is less than B, so angle A needs to be less than angle B. Now angle A is 35 degrees, and you'll notice both of these answers for angle B are bigger. So both of them work. And this is where we'll get two different triangles from the same information. This is our ambiguous case. If we go back to our diagram here, this is where angle B would be in our first one. Here's angle B in the second one. As we can see, angle B here is about maybe 30 or 40 degrees, whereas here, this is actually quite a lot bigger than 90 degrees. And from our answers, we see one's about 40 or 50 degrees, and the other one is well over 90 degrees. So it does match the picture in the two possibilities here. In this case, when it says solve, we need to solve both. They're both equally valid. I'm going to do it as a T-chart here because the steps for one are going to mirror the steps for the other. We do the exact same thing for both, just with different numbers. First, we find our angle C by subtracting the two angles we know from 180. Next, we'll use our sine law, isolate for our last side. After we isolate for C, we can plug in our numbers, and we get our answer for the side here. We can do the exact same thing, just plugging in our other numbers, and here would be our final answers in both cases. Notice when C is large here, we have a large angle, and when C is small, we have a smaller angle. For help visualizing exactly how it works when we have the three different possible cases for ambiguous sine law, 0, 1, or 2 triangles, there's a link here that I'd love you to check out. This is an interactive applet where you can adjust the values for each side as well as the angle, and you can see the different cases. So for example, this was our first example that we did in our first video. As you can see, A is not quite long enough to reach the other side where this triangle would be completed, so there's no triangle possible. A is just too short. This was our second example. As you can see, there's one way that we can get these two sides to match up, but if we swing it off in the other direction, 30 degrees isn't part of our triangle anymore, so there's only one triangle possible. And this was our most recent example, where we can see there are two possibilities depending on how you angle our side A, that both satisfy all the conditions from our problem. So feel free to play around with this. I think it's pretty fun. I encourage you as well to use this while you're doing your homework problems to help visualize the questions you're working on. Now you might be wondering to yourself, when would this actually be used for any real-world calculation? And one of the places where this ambiguous case comes up a lot is in astronomy. Here's a problem that uses this ambiguous case. We're told the distance from Earth and Venus to the Sun, and imagine we were making an observation from Earth that told us the angle between Venus and the Sun is 25 degrees. And we want to know how far Earth is from Venus. Let's say we were doing some astronomy calculations that needed to find this distance. As with all word problems, we need to draw a picture in order to do this. So here's using two pieces of information, the distance from Earth to the Sun, as well as the angle between Earth and wherever Venus is in this case. Now, if Venus is 110 million kilometers from the Sun, it could actually be at an angle like this, or it could be angled away. So here's our diagram. I've drawn in the circles that indicate the orbits for Earth and Venus. Now the book has a really nice picture of this on page 293. So if this is a bit messy for you, I encourage you to take a look there. Now in this problem, we want to solve for the side across from this angle S. So if we can figure out what this angle S is here, we can figure out the side across from it. So either that's going to be this smaller distance or this larger distance. But notice we have an angle and a side across from it as a pair here. So we can use this side right here to figure out what these two angles could possibly be. So using our sine law, we have the sine of our angle E here, 25 degrees, and the side across from it, which is 110, as well as the angle V here, as well as the side across from it, 151. Now we know the angle E, so let's try and solve for the angle V here. Just like before, we can solve for the sine of the angle. Remember that when we solve for the angle here, using the inverse sine, it's either this angle or it's 180 degrees minus this angle, because remember, this is a reference angle. So it's either this one if it's in quadrant 1, if it's in this example here, or it's 180 minus that in quadrant 2, which would give us this triangle here. Now these are both equally valid and we need to solve for both. But the solution is going to look exactly the same as what we did before. Subtracting the two known angles from 180 to find the angle S gives us these two answers. And remember, we want to try and find the side across from this. That's the distance between Earth and Venus. We'll call that side little s. So using sine law and isolating for our side little s here, after we rearrange it and plug in our values, we get that the side s, which is the distance between Earth and Venus, to be about 226.4 million kilometers. And we can do the same thing over on the other side. And instead we'll get 47.3 million kilometers. What this tells us is that when the angle at the sun is large, which is the case where we have this wide triangle here, the distance is larger. It's 226 million kilometers. But when this angle is small right here, as in our second case, this distance is small, only 47 million kilometers. This would be really important to an astronomer because without the knowledge about this ambiguous case, they might only think there's one possible distance. That's the end of the video here. Check out the homework that I posted on Teams or the weekly assignment, and I'll see you all in the next video.